Today we're going to be talking about how to solve systems of equations, both linear and nonlinear. So this is section 7.2 and 7.1. We're going to be solving systems with two variables. Now, whenever we talk about solving a system, we have a few tools that we use. Everyone knows substitution and elimination. These are sometimes referred to as algebraic techniques. We also have graphing. Now, the problem with graphing is it gives us an approximate answer, and we could use to check an answer. We don't really use that to get an exact answer because graphing gives us an imprecise answer. We could also use a calculator. Now, on the calculator, we could turn a system into a matrix, and then we could solve it. This only works for linear systems. Today what I wanted to do is just focus on the algebraic techniques. Now we have different types of solutions. We have actually three types. One type is no solution. And we'll see this using algebraic techniques if you get an answer where it's like 0 is equal to 2. You could also have a solution where it's a finite number. That's where you get like x is equal to 1, y is equal to 3, or something similar to that. Sometimes this is called a consistent and independent system. The first one is called an inconsistent system. And you could have no solution if you have parallel lines. Second type of solution would be lines that cross in one place. Or it could be any kind of shape that crosses another shape. And then the third type, we have infinitely many solutions. And you'd get an answer like 0 is equal to 0 for this. And this is called consistent and dependent. And what this pretty much means is this means that you have the same line. So this would be if you had a line where it's like x plus y is equal to 2, or 2x plus 2y is equal to 4. You could see that it's the same line. I just multiplied everything on top by 2. So now let's take a look at some examples. First, let's look at some linear systems. We'll solve these using algebraic techniques. So for 5x plus 3y is equal to 9, and 2x minus 4y is equal to 14. Probably the easiest way to do this is by using elimination. You could use substitution if you want, but seeing as it's not that easy to get one single variable by itself, I'm going to use elimination and eliminate the y's. So remember, when we're doing elimination, we want to get let me write this down here, the elimination. We always want to get the opposite sign and the same number. For example, we want to get like maybe a 3y and a negative 3y. Same number, but opposite signs. And we always add the two equations together. So let's do that here. I'm going to multiply the top by 4, multiply the bottom by 3. We get 20x plus 12y is equal to 36. On the bottom, we'd get 6x minus 12y is equal to, well, 2 times 14 is 28. 28 plus another 14 would be 42. If we add them together, we get 26x is equal to 78. And in this case, x would be 3. Remember, don't get too excited once you get 1. You have to plug it in and figure out the other variable. So 2 times 3 is 6, minus 4y is equal to 14. We could bring over the 6, and we'd get 8. So y would equal negative 2. So this would be an example of a finite number, which would be consistent and independent. One more example. What if we had a problem like this? 0.02x minus 0.05y is equal to negative 0.38, and 0.03x plus 0.04y is equal to 1.04. Now the decimals do make things a little bit trickier, but if we just multiply everything by 100, we can get rid of all the decimals by moving it 2 places to the right. So this would just be 2x minus 5y is equal to negative 38, and this would be 3x plus 4y is equal to 104. Again, using elimination, we can multiply the top by 3, maybe the bottom by negative 2 to eliminate the x's. So we'd get 6x minus 15y is equal to negative 38 times 3 is negative 114. And on the bottom, we get negative 6x minus 8y is equal to negative 208. So negative 23y would equal negative 114 minus 208 is negative 322. And we get y is 14. If y is 14, we could plug them into any equation. And let's see here, 4 times 14 is 56. So 104 minus the 56 is 48. And if we divide both sides by 3, we would get 16. You could write your answer like this if you want. You could also say 16 comma 14. It doesn't matter how you choose to write it, but this would be a consistent and independent solution. And to finish up today's lesson, I want to talk about nonlinear systems. We're going to solve these the same way. First example says x squared plus 4x minus y is equal to 7, and 2x minus y is equal to negative 1. Now the top equation has one quadratic, so this would actually look like a parabola. One quadratic gives us a parabola, two quadratics, like x squared and y squared, would give us, it could be an ellipse, it could be a circle, it could be what's called a hyperbola, but the top one's going to be a parabola, and we have a line. So we're looking to see where do a parabola and a line cross. So let's see here. I mean, if we do elimination, we could eliminate the y's, and that's fine. We could also do substitution and solve for y and then plug that in. So either way would give us the right answer. We did elimination for the last two problems, so maybe I'll use substitution for this. I'll bring the y on this side, I'll bring the 1 on this side. So we get y is equal to 2x plus 1, and then we could take that value for y and plug it into that equation. So we get x squared plus 4x minus 2x plus 1 is equal to 7. We could distribute the negative, and then bring the 7 on the other side. When we go to solve this, we get, we'd have to factor, and we could use positive 4 and negative 2. So we actually get two x values, negative 4 and positive 2. The way that we always solve systems is we have to plug them in, right? So plug them into either equation. I mean, generally we use the original equations in case we made a mistake, but it doesn't matter. So let's plug it in for x and see what y is. No matter where you plug it in, you'll get that y is equal to, well, 2 times negative 4 is negative 8, plus 1 is negative 7. And 2 times 2 is 4, 4 plus 1 is 5. So you get the answer is negative 4 comma negative 7 and 2 comma 5. So this kind of graph would look something like that. It would cross in two places. And then our last nonlinear system would look like negative x plus y is equal to 4, and x squared plus y is equal to 3. So again, we could use elimination or substitution. We could multiply to get rid of the y's, or we can get y by itself and then substitute in here. It doesn't matter which way we do it, so I'll just choose to do elimination. I'll multiply this top equation by negative 1, and we get x minus y is equal to 4, and we get x squared plus y is equal to 3. Remember, when we are doing elimination, we always add. So we're going to add here x squared plus x. I mean, you can't combine them, so it's just x squared plus x. Negative y plus y cancels. 4 plus 3 is 7. So we get x squared plus x minus 7 is equal to 0. And let's see, factors of 7. Yeah, I don't think that's actually going to work factoring, so let's try quadratic formula to solve. We'll use the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And actually, you know what? I just noticed I made a mistake here, so let me just back up a little bit. When you multiply by negative 1, make sure you multiply everything by the negative 1. So this should be negative 4. So negative 4 plus 3 is negative 1. And if you bring that over, that becomes positive 1. All right, well, that still doesn't factor, so let's go ahead and use our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And we get x is equal to negative 1 plus or minus the square root. 1 minus 4 is negative 3. So what this means is we get an imaginary answer for our x values, which means that there's no solution. This is an inconsistent system because of that imaginary values. So sometimes if it's linear, you might get like 0 is equal to 2, like we said initially. But if you get an imaginary number when you're trying to solve a system, that's another indication that it's no solution. What this actually looks like is this would be a parabola, this would be a line, and it looks like the two don't cross. It would look something like that. All right, so for homework, this is what I would like you to please do. On page 496, I would like you to please do numbers 31, 35, 55, and 59. And then on page 505, I'd like you to please do numbers 25, 27, and 29. Thank you very much, and have a nice day.